Good morning, Honors Algebra 2. It is Thursday, April 16th, and we're going to leave graphing behind until our quiz and test, and we're going to go ahead and start section 13.6. We're going to spend 2 days on this, and this is on the fundamental identities of trigonometry. And identity is kind of just like a rule or a equation or a statement that is always considered to be true. Now, I've copied the gray table that's on page 636 in your textbook, and you can follow along while looking at that. But there's 3 different types of identities that they're going to talk about today, and that we're going to talk about today. And you know a lot of these, okay? I want to start by mentioning the co-function identities. Now, we've had these before. We talked about these in the last trig chapter, and that the sine of an angle is the same thing as the cosine of the complement of that angle, and so forth and so on, and all of those. I'll be honest with you, we are really not going to do much with these co-function identities in this chapter. So don't worry yourself with those, but those are considered trigonometric identities. Okay, now let's go up to the top and talk about these 6 reciprocal identities, and you know these. Now they're using alpha, the Greek symbol alpha, here for an angle. You can use theta, you can use x, so don't be concerned about that. But the sine of alpha is equal to 1 over the cosecant of alpha. You know that sine and cosecant are reciprocal functions. Likewise, on the far right over here, the cosecant of alpha is 1 over the sine of alpha. Now, if we go down to the next line, we have the cosine of alpha is 1 over the secant of alpha, and to the far right, the secant of alpha is 1 over the cosine of alpha. So you know those. That is not a problem. Now, in the center section, it makes sense. If you multiply a fraction times its reciprocal, your product is going to be 1. So if you take the sine function and multiply it by its reciprocal function, the cosecant, you're going to get 1 for a product. Same thing as cosine of an angle times its reciprocal secant, it equals 1. So we really are comfortable with all those. Also, these. The cotangent of an angle is equal to 1, the tangent is equal to 1 over the cotangent, and the cotangent is equal to 1 over the tangent. And if you multiply the reciprocal functions, you get a product of 1. So we're good with that. Now, what's new is this. The tangent of your angle is equal to the sine over the cosine, and the cotangent is equal to the cosine over the sine. Now, I'm going to show you how those work on another slide, but those are new reciprocal identities that you need to know and know how they work. Now, there's also 3 important Pythagorean identities, and I'm going to explain these to you in the next slide also. But the main one that you really need to know, that you'll see more than any other, is your sine squared of your angle plus the cosine squared of your angle is equal to 1. And look what I did. I covered up the 1 there. And then these other 2 are derived from this original identity on the left. So let's take these circled identities. There are 5 of them in all. And let's see why they are true. Why are they true? Now I'm going to go ahead and go out of this, and let's go to this section here. Now, what I've done on the right side is I've gone ahead and drawn an angle in the first quadrant and created a triangle in there. And so we know that the horizontal distance across, let me get my pencil here. The horizontal distance across is x. And why is my pencil not working? Why is my pencil not working? There, it's working now. Okay. All right, my horizontal distance across is x. My vertical distance up here is y. And then r is my hypotenuse. And you've learned down here, look at your bracket here, your brace. The sine of an angle is y over r, cosine x over r. Tangent of your angle is y over x. Now, you've known this from the previous chapter, but let's see how that works to figure out this first important reciprocal identity. The tangent of theta is sine over cosine. So let's go ahead. We know that the sine over the cosine Well, let's go ahead and use this information over here. The sign is y over r. So we're going to start with our numerator, that's y over r, and we're going to divide it by the cosine of theta, which is x over r. Now let's just do some basic math from elementary school. To divide means to multiply by the reciprocal, and my r's will cancel out, and what do I get? Y over x. Well, what is y over x? Y over x, we see over here, is the tangent of theta. So the tangent of theta is equal to, let's get rid of this now, is equal to the sine of that same angle theta divided by the cosine of theta. So that's a really important one to know. Now let's move down to one of our basic Pythagorean trig identities and see how that's derived. So the sine squared of theta is the same thing as y over r squared, because remember, the sine is y over r. I'm going to add to that the cosine of theta squared, which is x over r squared. And we're saying that's equal to 1. Well, let's go ahead and simplify this. Y squared over r squared plus x squared over r squared equals 1. Now, let's go ahead and combine our denominators and make one fraction on the left side. I'm going to go over here. Y squared plus x squared over r squared equals 1. Let's multiply both sides by r squared. I get y squared plus x squared equals r squared. Well, doesn't that look a lot like the Pythagorean theorem? Well, it's a Pythagorean identity. Now let's go ahead and go blue and go back up here. Does y squared plus x squared equal r squared when I have a right triangle? Absolutely. And so we have just shown that the sine squared of an angle plus the cosine squared of an angle is equal to 1. Now, once you know that, what you can do is, I'm going to get rid of that squiggle. What you're going to do now is we can derive the other two Pythagorean identities that are at the bottom of that gray table on page 636. And the first thing I'm going to do is I'm going to take my basic Pythagorean identity that we just derived, and I'm going to divide every term in the equation by sine squared theta. So I'm going to divide everything by sine squared theta. And what do I get? This becomes 1 plus, well, I've got cosine over sine. Well, cosine over sine is, well, let's go back up here. If the tangent of, well, what am I doing? If the tangent of theta is sine over cosine, then the cotangent of theta is going to be the reciprocal, the cosine of theta over the sine of theta. So we have that reciprocal function. So down below again, cosine squared over sine squared is going to simplify to cotangent squared theta. And what is 1 over sine squared? Well, 1 over sine squared is cosecant. So I've got cosecant squared theta. And if you look at your table, this is actually the third listed Pythagorean identity. 1 plus cotangent squared theta equals cosecant squared theta. Now, they use alpha, but no big deal. Now, guess what I'm going to do here? I'm going to take the same original Pythagorean identity, and I'm going to divide everything by cosine squared theta, cosine squared theta, cosine squared theta. And sine squared over cosine squared, we learned, is tangent squared theta plus 1 equals, well, 1 over the cosine is going to be the secant, and so I'm going to get secant squared theta. So let me box that. Whoa, there we go. I'm going to box this one. Both of these are your second and third Pythagorean identities in trigonometry. These are statements that are always true, and can be proven to be true. All righty, let's move on and see how we can apply some of these identities to help us simplify trigonometric expressions. So the first thing we want to do is, I'm just going to take an example. There are so many of these, and you're going to do some for homework tonight. And I can't possibly do every single type there is, but I'm going to go ahead and just do a couple to give you a feel for how this works. You will just be doing odds, so you'll have the answer in the back. So you'll know what you're trying to get to in the end. You'll just have to figure out what trigonometric identities can you use to get from point A to point Z. And hopefully not point Z, it'll probably be point E or D. Okay, now, first thing I'm going to do is I want to simplify this expression into one single expression, like the cosine of alpha, or the secant of alpha, or the cotangent of alpha, something that's much more simple than this. So one technique that works really well is to start by writing the function in terms of the functions in terms of sine and cosine. So this one is already cosine alpha. I'm going to leave that alone. And alpha is just another Greek symbol to represent an angle. And then, oh, we have just learned that the tangent of an angle is equal to the sine of that angle over the cosine of that angle. And then I'm going to multiply that by the sine of alpha, because that's that little part right there. So I've just taken the tangent and converted it to sine over cosine. Now let's simplify this. That's going to be the cosine of alpha plus sine squared alpha over cosine alpha. Now, what if I wanted to go ahead and take cosine alpha, this first term, and write it with a common denominator? So if I wanted to make the denominator, let's go ahead and copy the second part. I've got sine squared alpha over cosine alpha. And I want to take this first term and write it with a denominator of cosine alpha. So what am I going to do? I've added cosine alpha to the denominator, so I've got to add it to the numerator to keep the fraction the same. And so I'm just going to now have what I started with, my cosine alpha, and I'm basically multiplying it by cosine over cosine. So I get cosine squared over cosine. So now I'm going to go ahead and combine these. Got one common denominator of cosine alpha. The numerator is cosine squared alpha plus sine squared alpha. Now, ooh, is this a trig Pythagorean theorem identity? You betcha. It's equal to 1 over the cosine of alpha. Now, how can I write the cosine of alpha without having a fraction? Well, 1 over the cosine is equal to the secant. So my final answer is the secant of alpha. And I took this complicated expression and rewrote it simply as the secant of alpha, using trig identities and just using basic algebra skills along the way, finding common denominators. Okay, now let's try one more. Let's try to simplify this fraction. Now, you should look at that top, and that should look familiar to you. Alrighty, now I wrote it down here. Here's our basic identity, Pythagorean identity, sine squared plus cosine squared equals 1. Well, look at this numerator. It's 1 minus cosine squared alpha, no, we're not alpha anymore, we're theta, over sine theta cosine theta. Now, what is 1 minus cosine squared theta equal to? Well, let's solve this identity for sine squared theta, and look what we get. The sine squared of theta is equal to 1 minus the cosine squared theta. Well, look at there. This is what I have over here. And so what I'm going to do is I'm going to replace 1 minus cosine squared theta with sine squared theta. You'll start to recognize these patterns as you go along, but you'll see things like this over and over again. Now, can I simplify this? Well, I've got sine squared over sine. Well, what's x squared over x? X. So the numerator, I'm going to end up with 1 sine in the numerator, and then cosine is going to stay in the denominator. Well, what did we learn that sine over cosine equals? Sine of an angle over the cosine of angle is simply the tangent of that angle. And I have just simplified this big old whopping thing into the tangent of theta by using my Pythagorean identity and then just using some basic simplification of expressions with algebra. Now, let's try one more thing that you're going to see on the homework tonight, and that is, it says to write the tangent of x in terms of the sine of x. So I want to take the tangent of x and rewrite it with just sine in it. Okay, now what's the first thing I remember? Well, we're going to use two things. First thing we're going to use is our basic definition of the tangent in terms of sine and cosine. And so that identity, I'm going to go ahead and write that. The tangent of x is the sine of x over the cosine of x. Now I'm supposed to put everything in terms of sine x, and I've got the numerator, I've got sine there, but I want this denominator to be expressed in terms of sine and not cosine. So that's where my Pythagorean trig identity comes in. Now, let's go ahead and I'm going to, where can I do this? I'm going to go ahead and just come down low here so you can see this. So I want to substitute in something for the cosine of x. So I'm going to start with sine squared x plus cosine squared x equals 1. Let's go ahead and solve for cosine squared x because we want to substitute the cosine for something else. So we're going to do 1 minus sine squared x. Okay, I'm getting really close here to express the cosine in terms of sine. But I have cosine squared. Well, we know that if I have x squared equals 9, what does x equal? Plus minus the root of 9, right? Which is plus minus 3. We know that. So let's do the same thing here. So the cosine of x is going to equal positive and negative the square root of 1 minus the sine squared of x. Okay. Now, let's just plug that in to the top expression here. So I've got the sine of x is going to stay the same up top. I'm going to replace the cosine of x with plus minus the square root of 1 minus sine squared x. And that is my answer. I have converted the tangent of x into an expression that only has sine in it. It only has sine in it. Oh, let me say this. Let me erase this. You really don't want to put your plus minus here. Let's do this. Okay, bye-bye. Let's do this. Let's go ahead. The plus minus really should go to the left of the fraction bar. And I'm glad I caught that before I ended my video. So that's a little messy, but that's what you're looking for. Now, you're going to have 2 days to work on this. We're going to learn how to do some proofs tomorrow. But today, we're just going to simplify some expressions. Look at the answer in the back to see what you're trying to get to and just show me the steps to get to it. Okay, now, you're also going to do your self-test. We've done a quiz on 3.1 and 3.2. We want to finish up 3.3 through 3.5, and I realize there's a lot of graphing there, and I'm not going to make you do more graphing. You've done a lot of graphing for me. You have your graphing worksheets there with the answer key, and so you just go over those, you know, before the quiz to review your graphing. But I will have you do a little bit. There's a few things I'm going to have you do on the self-test, and we will have a quiz Friday on 3.3 through 3.5. Okay, so do the homework in the book on this, do your self-test. Remember, I do have some Khan Academy on, I think, amplitude and period, and max and min, maybe midline type stuff. That's due Friday at midnight. So go ahead and work on that. I'm going to take those three, combine those 3 scores into a quiz grade, a trig quiz grade for you. So, and remember, you can take those more than once. So if you're not been happy with your quiz grades, then this is a great opportunity with that Khan Academy to get a good score in your quiz grade. So anyway, we're doing some hard stuff together here online, and I appreciate it. Y'all have really been working hard, and I will talk to you tomorrow, and come see me during the Zoom meeting if you need help before you take the quiz, even if you need some clarification on how those graphs work. Okay, all righty, have a blessed day. I miss you, and I hope to see you soon. Bye-bye.